When creating new components in the context of an existing design, the geometry of the new component can be determined by the positions of the surrounding components. Because Fusion 360 uses a single environment to design parts and create assemblies, the positions of the components are extremely important to the design process. To help specify and track the positions of components in the model, Fusion 360 uses Capture Position that captures the positions of all components relative to one another. Capture Position isn't a command that can be invoked by the user, but is more of an option that's made available when components are moved in the model. For instance, if I rotate this rotor in the Geneva drive, notice at the top of the toolbar that there are two position options available: Capture Position and Revert. If I click Revert, the components move back into their previous positions before they moved. This is useful if you need to check how components move in the assembly but don't want to actually shift their positions. If I move the rotor again and click the Capture Position option, it remains in its current position, and a position feature was added to the timeline. This feature is parametric, meaning that it is a part of the order of features and can be used to create additional features downstream. If I roll back in the timeline before this captured position, the rotor moves back to its position prior to the position being captured. And when I roll forward, it returns back to its new position. Capture Position can also be suppressed if needed. I'll right-click on it in the timeline and click Suppress. Now the rotor moves back to the last position. For now, though, I'll keep this capture active and unsuppress it. Captured positions aren't applied to just individual components. It captures the positions of all components at once. So, if I go ahead and rotate both the rotor and the crosspiece to new positions and capture position, you can see that both components move when the feature is included and excluded from the timeline. Captured positions are particularly helpful when creating new components. Because new components can be created in context to other components, their positional geometry can determine the new component's design. For instance, if I view the model from the top view, and rotate the cross and rotor components so that the hole on the rotor lines up with the slot on the cross, I can capture the current position of the components. I can now create a new peg component that references both the cross and the rotor. I'll be sure to create a new blank component within the rotor subassembly, and then activate it so all geometry I create is contained in this component. I'll create a sketch on the top face of the rotor, then project the circular cutout and the two lines along the cutout. Now I'll draw one more circle concentric with the first, so that it's tangent to the nearest edge, and stop the sketch. Now I'll create the peg using the Extrude command. I'll enable it, then select the smaller circle and extrude it -10 millimeters going down into the rotor. With this component still active, I'll show the same sketch, and create the upper half of the peg using the Extrude command again, which will also go upward 10 millimeters. Because I was able to capture the positions of the cross and the rotor, I could create this peg in the context of the positions of the surrounding components. Now I can use this peg to enable the motion of the Geneva drive. I'll turn off the sketch I just created, activate the rotor subassembly, and create a rigid group between the peg and the rotor. Now I can quickly create a contact set, which will enable the cross and the peg to interact when their surfaces come into contact. I'll dive deeper into contact sets in the next lesson, so for now, all you need to know is that the two components will now move one another when they come into contact. When I rotate the rotor and peg, you can see that the crosspiece also moves when the peg comes in contact with it. I was able to accomplish this by utilizing capture position, which produced the in-context geometry I needed to create the right-sized peg.